Alright, let's just take a look at these different types of trig graphs here. I'm going to start with y equals the sine of x, just so we're comfortable with manipulating that one. Essentially, when we're looking at trig graphs, we want to look at a couple of different things. We want to look at the amplitude, the period, any vertical shifts, and any phase shifts. Okay, what are those things? Well, the amplitude can be thought of as the height of the graph from the center line. The period is the distance required for the graph until it repeats. Vertical shifts is really what it's saying, just moving up and down. And phase shifts are moving left and right. So, I want to look at my original graph over here, y equals the sine of x, and I want to sketch all of these from the domain of 0 to 2 pi. So I'm very comfortable with that typical sine graph. I know that it resembles this shape, just like that. And I also know that it reaches heights of 1 and negative 1 on the y-axis there. Label my axes. Okay, what do I know about this one? Well, in this case, right, the amplitude is just 1, because that's the distance from the center line to its highest point. The period is the distance until the graph repeats. Now, I'm only drawing from 0 to 2 pi, but if I kept extending it, you would see that at the distance of every 2 pi, that's how often the graph repeats. So it'd just be 2 pi there. What else do I need? Are there any vertical shifts? Well, there's no constants there, so I'm not shifting it at all. And there's no phase shift, so there's nothing happening inside the brackets there. How do I exactly know that? How do I generalize this? Well, it looks something like this. Essentially, if I have any constants multiplied on the outside of my sine graph, that's going to affect the amplitude. Okay? So if I had a 5 there, the amplitude of the graph would be 5. If I have a 2, it would also be 2. For D, those are going to affect my vertical shift. So if I add a constant at the end of my trig graph, that's going to push it up and down. Those are my vertical shifts. B is interesting. What is B in terms of this bracket? Well, B is just the coefficient of x. It's just the number in front of x, right? So, to find the period in terms for a sine graph, what you need to do is you need to find 2 pi over b. Now, in this case, if I look at the coefficient of x, the coefficient of x is just 1, right? And so the period is just 2 pi over 1, or we can just leave that as 2 pi. So that's how I actually find the period for my typical sine graph there. And last but not least, I can have phase shifts here if I have a constant on the inside the brackets there. In this case, there are no constants there, so I don't have to worry about that. But we'll look at some examples of that. Cool. Okay, let's look at this first one here, right? And it's a really good habit just to do when you're drawing these graphs, to label and identify any features. So first of all, you know your amplitude is going to be the constant that's multiplied outside of that whole function, so that's going to be 5. You also notice that nothing else has changed about this one, right? We still have just a single x inside the brackets there, so my period is just going to be 2 pi still, because the coefficient of x is just 1, 2 pi over 1 is just 2 pi, and there's no constants added inside there. So I can just draw the graph as per normal. Now, a little trick when you're drawing these trig graphs and they're manipulated, what you can do is you can just think about what the graph would look like and then put in your values afterwards, so that you're not trying to fit your graph into some weird kind of scale. What I mean by that is, the only difference about this one is that the amplitude's changed. So, when I'm drawing this, I'm still going from 0 to 2 pi. That's what the question asked me. And because the period hasn't changed, I'm going to be drawing pretty much the same graph. It's just going to be a bit taller, right? And I don't have to reflect that necessarily from different questions. The important thing is that you keep to your own scale. So 5 and negative 5. And that's how you would draw 5 sine x. Should label my axes there. Cool. Okay, now I come to something like this, and I notice now that there's no constant on the outside of the whole function. So my amplitude is just going to be 1. What about my period? My period has actually changed now. I know that the period is equal to 2 pi divided by the coefficient of x. In this case, I've got 2 pi on 3. Okay? And I know that there's no other vertical or phase shifts going on because that's the only manipulation they've done there. What does this do? What does a period of 2 pi on 3 actually mean? Remember, what's your definition of a period, right? It's the distance required for the graph to repeat. So far in these cases, it's just been 0 to 2 pi, so I've seen one instance of my sine graph there. This is going to be a bit different though. 2 pi on 3, if you're not so comfortable with radians, that's essentially 120 degrees. Okay. So every 120 degrees, or every 2 pi on 3 radians, I expect my graph to repeat. Now, when I'm doing that on an interval from 0 to 2 pi, have a think. How many times would you expect that to repeat? If I've got 120 degrees and 2 pi, which remember is 360 degrees, well, you just expect it to repeat 3 times, right? And so, when I'm drawing my graph, y equals to sine 3x, I'm going to be thinking, okay, when I'm going from 0 to 2 pi, I want to repeat my graph, my sine graph 3 times. So, before I even do any markings, I'm just going to draw it out. 1, 2, and 3. Probably extend my axis a bit there. And can you notice now that I've done that, I've kept my graph relatively to scale in terms of these sine graphs here look pretty much the same, these repetitions. And after I've drawn it in, then I'll put in my markings. Now, I can see that the graph repeats at these intervals here. That first interval should be 2 pi on 3. What would the next one be? Well, I'll just add another 2 pi on 3 on top of that, right? Because it's meant to repeat every 2 pi on 3 at a distance of 2 pi on 3 along the x-axis. So if I add 2 pi on 3 and 2 pi on 3, you just get 4 pi on 3, right? And make sure to put in your values for the y-axis. That's just going to be 1 to -1 because that's your amplitude there. Sweet. Last one now. I've got an interesting thing here. It's like a combination of all of these. Essentially, I just want to put all these pieces together and see what happens. So, let me write down any information I can see first. I can see that A, the amplitude is going to be 2. Are there any constants here? Yeah, I can see that there are constants here this time. I've actually got a vertical shift of 1 there, so just got to be careful of that one. What's the period going to be there? The period's going to be a bit different, isn't it? And the period is 2 pi divided by the coefficient of x. What's the coefficient of x in this case then? Well, if I have x on 2, the coefficient of x is actually going to be half. So that's 2 pi on half. Or if you take the reciprocal and change it to a multiplication sign, you're going to get 2 pi times 2, or just 4 pi. Okay? So it's saying at a distance of 4 pi, that's when my graph repeats. So there should be brackets around there, just to make that clear. What I want to do here first is I want to put this together piece by piece, right? So I want to start by thinking, okay, if I just had from 2 to -2, that's what my graph would look like. But I've got a vertical shift of 1. I'm adding 1, so it's going to be increasing the height by 1. So I'm actually going to be going from 3 to -1, because I'm increasing it by 1 there, okay? Sweet. And now I'm thinking, okay, now my center line isn't just going to be the axis, is it? It's going to be halfway between these points. What would that be? Well, that would just be at a y value of 1. So that's where I can draw my new center axis there. Okay. And now I want to think, how does this manipulation help? If I'm only going to, if my period is 4 pi, it means I expect to complete one repetition of the graph at a distance of 4 pi, right? But if I'm only going from 0 to 2 pi, what does that mean? Well, that means I'm only going to complete half of my graph. What's half of a sine graph? Well, it's just that top bit up there, isn't it? So all I would do is I would just go from my starting point over here, draw all the way up, reach up to 3, and then come down there. In the middle there I would have pi. Okay? That's it. That's how you can put together all these different pieces into a sine graph. I'll just do one more with you guys for a phase shift example. Here I've got sine of x plus pi on 2. So when you see these brackets here, you know when you've got a manipulation inside the brackets, you've got a phase shift. What that means is you're going to be moving your graph from left to right. How exactly does that work? Well, you notice that everything about the graph is the same. The amplitude is still 1. Your period is still going to be 2 pi, okay, because the coefficient of x is still 1 here. But what does this value of pi and 2 do? How does that affect it? There's a couple of different ways you can think about it. One way you can think about it is, usually, you're used to starting at x equals to 0 for y equals to sine of x. So one thing you can do is you think, okay, how do I get this new expression, the stuff inside the brackets, to be equal to 0? Well, if I've got x plus pi on 2, and I want that to equal 0, well, x would equal to negative pi on 2, wouldn't it? Right? What that means is, you can think about where your normal sine graph starts, which is usually here, but instead, you're shifting it to the left now. It's actually going to be starting at x equals to negative pi on 2. That's where it's going to be starting. Everything else would stay the same there. Right, because the period hasn't changed and also the amplitude hasn't changed. Right? So if I draw this out now, it should look something like this. Should I move that negative 1 down there? Can you see? Even though I'm starting at negative pi on 2 and I go to 3 pi on 2, that distance there, that is actually still 2 pi. If you add 2 pi onto that one, you'll still end up here, right? And that will keep repeating and repeating. I said there's 2 ways you can think about the shift. Another way you can think about it is when x equals to 0, what will pi on 2? Oh, sorry, when x equals to 0, what will this expression be? And that's just going to be sine of pi on 2, which is just equal to 1, isn't it? Right? So if I'm actually sketching this from 0 to 2 pi, what I should really do is remove this bit. I'll put it in dots so you can still see it part there. And then continue this part of the graph, which, remember, is still just your sine wave, but you end it at 0 to 2 pi. What you'll notice, funnily enough, is that this actually looks like a cos graph, doesn't it? And this is how you get one of your identities, that the sine of x plus pi on 2 is equal to cos of x. So that's one of the identities there, and you can see that graphically, how you get that.